Hello everyone, today we are presenting our work 3D Ego, which is a 3D editing framework. This work is done in collaboration with Wayne State University. In this work, we try to propose a single stage process for 3D editing and try to eliminate three-stage workflow. We achieved efficiency by bypassing the need for call map and avoiding model initialization on unedited original images. As you can see on this example, other methods like instruct nerve to nerve first initialize the poses and then train a model on original unedited images. However, in our case, in 3D Ego, we eliminate the requirement of call map and we also do not initialize the model on original images. So in our framework, we propose that you can record any video and then you can pass a textual prompt and the output will be a 3D trained model. In this work, we integrate SAM with LLM to achieve local editing. The contribution of our work is it is the first pose-free 3D scene editing framework. Another contribution is that we also propose and prepare GS25 dataset for this work. We achieved consistent multi-view 2D editing with help of LLM and SAM. Our autoregressive editing approach modulates IP2P score estimates in such a way that we can estimate our noise based on the already edited adjacent frames. Here you can see we are trying to play around with different terms in IP2P scores. Here we will just give a brief recap about Gaussian subletting. It's an approach which is alternative to NERV. NERV is an implicit representation while Gaussians are explicit representation, and each Gaussian consists of different parameters such as mean, covariance, opacity and color parameters. Here we introduce our training mechanism which consists of two parts: local optimization and global optimization. In local optimization, with each new frame added, we use a pre-trained depth estimator and then try to estimate the relative poses. We basically try to learn an affine transformation matrix and then we gradually expand the 3D scene. While expanding the 3D scene, we increase the density of the Gaussians under reconstruction as new frames are introduced. And we also regularize the estimated pose using chamfer distance. We also introduce numerous other losses which help us regulate our training and achieve better results. Here you can see some of the qualitative results. Over here you can see in our framework, since we are using SAM, we can achieve local editing. And we can also achieve geometric editing, as we have also proposed and represented some of the results where we basically try to remove the object. For object removal, we also use Llama as an inputting tool. Here we are also doing some 3D editing comparisons. So for example, this is an original scene of a van, and when we pass a prompt, give the blue color to the wheels and make the recycle beams browns, instruct nerve to nerve fails to handle this multi-attribute editing prompt. In our case, our framework successfully achieves the results. There is another result where we are trying to change the beard into blue. Here, some of the geometric editing results are presented where we are comparing our method with Gaussian grouping. As you can see, our approach surpasses Gaussian grouping in 3D object elimination across different scenes from GS25 and Tungsten Temple dataset. Here we introduce our prepared dataset, which is prepared using casually recorded videos from a phone. It contains a variety of scenes. In quantitative results, you can see with pose unknown methods, our method performs well under most of the settings. However, in pose unknown method, we can achieve better performance as compared to any other method such as knob nerve or perf. So basically we have eliminated the need of call map. We do not initialize model on unedited images. We have incorporated LLM for 3D scene editing. The limitations are we still need to do the model training on edited scenes. It's not a generalizable 3D model, and it's also not a one-shot editor. With all, I will finish my presentation. Thank you.